Hello everyone, how are you all? I hope you all are doing very good. In the last class, we discussed about how to draw the ray diagrams of myopia and hypermetropia with the measurement in detail perfectly. If you did not watch that video, just click the link in the top right corner I button, you can go to that video. So in today's class, what we are going to discuss, we are going to solve problems on myopia and hypermetropia. There are basically two types of defects. Those are myopia and hypermetropia. How they'll ask questions on myopia, how they'll ask questions on hypermetropia, how to identify the defect as myopia or hypermetropia, and how to solve the problem and how to find the focal length and how to find the power of lens of suitable for that person or for that candidate will solve everything on myopia and hypermetropia in today's class, right? So first let us discuss about myopia. Myopia is also known as nearsightedness. That's right. Nearsightedness means what? The person suffering with myopia will be able to see things which are placed nearby, but he will not be able to see things which are placed far away. That's why I wrote, see here, this is a normal human eye. Until 25 centimeters, nobody will be able to see clearly. Correct? After this, until 175 centimeters, he is able to see clearly. After 175, he is unable to see. That's why this I named as visible region. This I named as invisible region for the person. Okay, now? So now this itself can be asked as a person is unable to see things which are placed farther than 1.2 meters. Which defect? Myopia. A person's far point is only at 2 meters. Means far point should be at infinity. But for the person suffering with myopia, far point will not be at infinity. Far point will be here somewhere 200 centimeters or 300 centimeters or 500 centimeters, like that. And another way of asking question is, a student sitting in a desk, in the last desk, he is unable to see things which are written on the board. So these are some types of questions that can be asked on myopia. Okay. Now how to solve the problem on myopia? When they gave, after identifying the defect is myopia, they'll give one question like this. For this question only we can frame as, person is unable to see things placed farther than 175 centimeters. Identify the defect and find the suitable power of lens. Okay. So now we have to give him one lens. We have to place one lens or give him one lens. What is the work of this lens here? This lens should support him to see the objects which are placed in the invisible region. Where invisible region ends, if suppose the lens is supporting him to see objects placed until here, is it possible? Is it sufficient? No, not sufficient. The lens is supporting him to see the objects placed until here. Is it sufficient? No, not sufficient. The lens should help the person in such a way that if the object is placed at infinity also, the person should be able to see clearly. Yes or no? That's why the object distance in myopia is infinity. And where is the image distance? Suppose object is placed at infinity, this length should create an image of the object which is placed at infinity within the visible region of the person. Where is the visible region of the person starting? At 175 centimeters. So V is equal to minus 175 centimeters. Why minus 175? Because the lens is here and you are left side only. Correct? So V is minus 175 centimeters. So now if you understood until here, U and V you got means remaining things are easy. Applying lens formula, 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to 1 by V. V is minus 175 minus 1 by U. U is infinity. 1 by infinity will be 0. So we are going to get focal length as minus 175 centimeters. So we got focal length as 175 centimeters. Now we have to find out the power of lens. Suitable power of the lens we have to find out. What is power of lens formula? Power of lens P is equal to 1 by F, and here F should be in meters. So convert this into meters, it is going to be minus 1.75 meters. Correct? So power P is equal to 1 by F is minus 1.75. So power P is equal to 175. 1.75 means 175 divided by 100. 100 goes up, it is going to be 100 divided by 175 minus, so it is going to be power P is equal to 25 4 is 100, 25 5 is 125, 25 6 is 150, 25 7 is 175. Yes, 25 7 is. So power is going to be minus 4 by 7 diopter. Power P is equal to minus 4 by 7 diopter. I hope you understood how to solve problems on myopia. Now let us go to the next one, that is hypermetropia. What is hypermetropia? Hypermetropia means far-sightedness. Far-sightedness means what? The person suffering with hypermetropia will be able to see things which are placed far away, but will not be able to see things which are placed nearby. You place object at infinity, he will be able to see. But if you place object nearer than 35 centimeters, nearer than 50 centimeters, he will not be able to see. If in a question, if you see the words like a person is unable to see things which are placed nearer than 50 centimeters, nearer than 100 centimeters, like those types of words if you see, it means that the defect is hypermetropia. Okay, na? And one more type of question is also there. How they will ask? A student sitting in the first bench is unable to see the things written on the blackboard. Which type of defect it will be? Means nearby. Nearby he is unable to see. So it will be hypermetropia. Okay, na? And one more type of question will also be asked. The near point of a human eye receded to 20 centimeters or 30 centimeters, means near point is here. If the near point is here, he will be able to see these things also clearly. But near point shifted from here to here. So what happens now? He is unable to see things clearly here. So these are the three ways of asking a question on hypermetropia. How they will ask? Near point receded away. Okay. Unable to see things placed closer than this much. Okay. Next thing, a student sitting in the first bench is unable to see things written on the blackboard. Three things of asking question on hypermetropia. So this is about the hypermetropia. Now to cure this hypermetropia, what we have to do? We have to give or suggest one lens to him, to this person, correct? What this lens should do? This lens should help him in such a way that if the object is placed in the invisible region also, he should be able to see. Correct? What will this lens do now? If the object is placed at 25 centimeter also, he should be able to see. Object distance u is equal to minus 25 centimeters. How will this lens help him to see the object which is placed at 25 centimeters? The lens will create an image of the object in the visible region of the person. Where is the visible region starting? Here. So this is the starting point of the visible region of the person, correct? So what this lens will do? This lens will create the image of the object here. Exactly here image it will create. Okay, na? So that's why the object distance for hypermetropia will be u will be is equal to minus 25 centimeters. Object distance for myopia, it is infinity. This is fixed here. Okay, na? Object distance for myopia is fixed infinity. Image distance in myopia they will give in the question. Okay, na? And what about the object distance for hypermetropia? Minus 25. This is also fixed. And what about the image distance? Image distance will be given in the question. See, now in this one, image distance is 35 centimeters. Minus 35 centimeters. And one more thing you need to remember in myopia and hypermetropia, In myopia also, hypermetropia also, u, v all will be negative. U will be negative, v will be negative. Why, sir? Why is it like that? Why? Because here you are placing lens and object is also on the left side only, image is also on the left side only. Correct? So that's why object distance and image distance both will be negative only in case of hypermetropia also and in case of myopia also. So now you got u and you got v also. Let us solve for the focal length of the lens now. 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v. V is minus 35 minus 1 by u. U is minus 25. So 1 by f is equal to minus 1 by 35 plus 1 by 25. Okay na? So now 1 by f is equal to, what can we do? 35 and 25. LCM how much it will be? 35, 25. 5 7 is 35, 5 5 is 25. So 5 5 25, 25 7 is 175 is going to be the LCM. Okay. So LCM is going to be 175 minus 35 5 is 25 7 is 7 minus 5, 7 minus 5 2. 2 divided by 175. So you got focal length as positive. 175 divided by 2. It is going to be 2 8 is 16. 70 minus 16, 1 2 7 is 14. 87.5 centimeters. It is going to be 0.875 meters. Now find the focal length. Sorry, power. Power P will be is equal to 1 by f. So power P is equal to 1 divided by 0.875. We can get power as 1000 divided by 875. It is going to be something around 25,000 divided by 875 divided by 875. 1.14. Power is going to be 1.14 diopter. Okay na? Now if you look at, we got focal length positive here. We got focal length positive means which lens we will use for hypermetropia? Convex lens. Which lens we use for hypermetropia? Convex lens. If you look at the problem we solved on myopia, see, we solved the problem on myopia. We got focal length as minus. Means which lens we are going to use? We are going to use concave lens for curing myopia and we are going to use convex lens for curing hypermetropia. Okay na? Now let us solve some more problems on myopia and hypermetropia for our better understanding. Okay na? If we solve more problems on myopia and hypermetropia, then we will get to know what are the ways of asking question on myopia and hypermetropia. For better understanding, we have to solve as many problems as possible. Then only we can be prepared for the examination. Okay. So first question let us take. A person cannot read newspaper placed nearer than 50 centimeters from his eyes. Nearer than 50 centimeters he is unable to A person cannot read a newspaper placed nearer than 50 centimeters from his eyes. Name the defect of the vision. See, look at the diagrams. Remember the diagrams neatly. See, nearer than 50 centimeters. Nearer than 50 centimeters here. So, the defect is hypermetropia. A person is unable to see things placed nearer than 50 centimeters from his eyes. Name the defect of the vision. So first defect of the vision is hypermetropia. Hypermetropia. Draw a ray diagram to illustrate this defect. This ray diagrams how to draw, already we drew all diagrams, you can refer that. List two possible causes. What are the causes of hypermetropia? Causes of hypermetropia. Causes will be hypermetropia. Increment in focal length. First cause will be increment in focal length. Second cause will be decrement in eyeball size. These will be the causes of hypermetropia. And next, draw the ray diagram to show how defect may be corrected using a lens of appropriate focal length. Right? Using a lens of appropriate focal length, let us find out the lens power now. Until where he is able to see, he cannot see until 50 centimeters. Means hypermetropia, what will be U? U will be is equal to minus 25 centimeters. What will be V? V is minus 50 centimeters. Okay. Now find the focal length. 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to 1 by V. V is minus 50 minus 1 by U. U is minus 25. So it is going to be 1 by F is equal to minus 1 by 50 plus 1 by 25. So 1 by F is equal to 25 and 50. LCM will be 50. 51 is 50. 25 to 50. 2 minus 1, 1. So 1 by F is equal to 1 by 50, which implies F will be is equal to 50 centimeters. Focal length is 50 centimeters means it is going to be 0.5 meters. Now find the power. How to find power? Power P will be is equal to 1 by F. So P is equal to 1 by F is 0.5. 5 by 10. 10 goes up. 10 divided by 5. So P is equal to plus 2 diopter. We got plus 2 diopter means which lens we have to use? Convex lens we have to use to rectify hypermetropia. Okay na? Now let us take one more problem. If we take one more problem, one second. Okay. Next problem. A boy uses focal length of 40 centimeters in his spectacles. Name the defect of vision he is suffering from. See, he is using a focal length of 40 centimeters. Focal length is positive. If focal length is positive, then power also will be positive. Correct? See, focal length is F is equal to plus 40 centimeters. So plus 40 centimeters. Plus means what? Focal length is positive means power will be positive. Power is positive means lens will be positive lens. It is converging lens. It is convex lens. Convex lens for which defect we will use? We will use for hypermetropia. So two causes of defect of vision also we just have seen. Next. Go to next question. A eye has a near point distance of 0.75 meters. What sort of lens in spectacles would be needed to reduce the near point distance to 0.25 meters? Means near point it should be 0.25 meters means 25 centimeters. Near point went from 25 centimeters to 75 centimeters means nearby he is unable to see. Are you getting my point or not? Nearby he is unable to see. Actually, this one will be the eye, correct? Eye will be here. Until here near point should be the 25 centimeters, correct? This near point went until here 75 centimeters, means he is unable to see in this area. Nearby he is unable to see, far away he is able to see. He is able to see far away and unable to see nearby. Able to see far away means far-sightedness. Far-sighted means what? Hypermetropia. So this defect is going to be hypermetropia. For this answer will start from here. So near point of distance 7.75 meters. What sort of lens in spectacles would be needed? Which spectacles will we need? Hypermetropia. We are going to use convex lens only. We are going to use convex lens only. Also calculate the power of lens required. Is the eye long sighted or short sighted? Which sighted it is? It is long sighted. It is long sighted, right? So next, he also asked us to calculate the power of lens also. How to calculate the power of lens? See now, see the question neatly. Hypermetropia, right? Hypermetropia means u is fixed. U is minus 25 centimeters. And what is v? It is 0.75 meters, means 75 centimeters. Now find the focal length. Focal length 1 by f is equal to 1 by v minus 1 by u. 1 by v, v is minus 75 minus 1 by u. U is minus 25. Okay. Now solve it. Minus 1 by 75 plus 1 by 25. So 25 and 75. LCM will be 75. 75 minus 75. 25 3 is 75. 3 minus 1. 2 divided by 75. 1 by f is equal to 2 divided by 75. So f will be is equal to 75 divided by 2. So f will be is equal to 37.5 meters. Okay na? So f we got, centimeters. So focal length will be 0.375 meters. How to find power now? Power P will be is equal to 1 by f. 1 divided by 0.375 meters. 3 zeros are there. So power P will be is equal to 1000 divided by 375. 1000 divided by 375, it is going to be around, if it is 300, 3.33, 5 7 is 35, 5 5 is 25, 5 2 is 10, 0 0, 5 15 is 5 40 is. So it is going to be 15 2 is 30, point 15 6 is 90, 2.6 diopter, around 2.6 diopter. Okay. So next question, let us take the next question. An eye has far point of 2 meters. What type of length in spectacles would be needed to increase the far point to infinity? Means the far point, it is not infinity now. It is only 2 meters. Means he is able to see only until 2 meters. He is unable to see until infinity. Understand the question neatly. An eye has a far point of 2 meters and see, an eye has far point of 2 meters. What type of lens in spectacles should be needed to increase the far point to infinity? Means he is able to see only until 2 meters. He is unable to see until infinity. Means nearby he is able to see. So it is near-sightedness. It is near-sightedness. Near-sightedness is nothing but myopia. For myopia, what will be u? U will be is equal to infinity. What is v? V is nothing but, which is given in the question, it is 2 meters. Okay na? So now 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v. V is 2 meters minus 1 by u, infinity. So 1 by f is equal to 1 by 2. So f is going to be 2 meters. Focal length is 2 meters. We have to calculate the power. How to calculate power? Power P will be is equal to 1 by F. P is equal to 1 by 2. So P is equal to 1 by 2 is 0.5 diopter. Is the eye long sighted or short sighted? Short sightedness. It is myopia. Okay. Now let us take one more problem. Yes. So this completes some model problems on myopia and hypermetropia. Hope you learned so many things regarding this myopia and hypermetropia. Thank you so much. If you need any concept to be clarified, ask me in comments. I'll definitely create video on the things which you ask. Okay. Thank you so much. Keep learning.